Okay, so this is a set of notes on scatterplots and correlation. Okay, so one of these, the scatterplots, are a graphical representation of something, and correlation is a number used to measure that a relationship that's revealed by a scatterplot. So the first thing I want to get out there are two terms that get used on the AP exam. One is called a response variable, and the other is what is called an explanatory variable. Now, in some studies, you have a response variable and an explanatory variable, but not in all. Okay, so you only say that you have a response and an explanatory variable when you have a reason to believe that this is the case. Okay, so the response variable measures outcomes. Okay, so like, I don't know, like weight gain or loss could be a outcome of a study, right? So that is an outcome. Excuse me. The explanatory variable would be um, basically something that helps predict DICT or explain the outcome. So this might be in our study of like weight gain or loss. An explanatory variable might be something like calories consumed per week, right? So it would more likely be that the calories consumed per week is explaining the outcome of weight gain or loss than like the other way around. Like your weight gain or loss is not necessarily explaining a change in calories consumed per week. Um, it's possible, but under most models, we would think that calories consumed per week is going to explain the weight gain or loss. Now, like you could also can create a situation where these two things are like just don't apply. Like if I try to look at the relationship between height and weight, right? It's not, or even better, let's do like height and arm length, right? Does your arm being longer make you taller? Does being taller make your arm longer? Well, these things seem to be correlated, but they don't, or at least have an association, but there's not a sense of one of them explaining the other one happening, right? So just kind of thinking that through. Not every situation gives you an explanatory or response variable. Typically, this variable, the explanatory variable, is represented as x. The response variable is represented as y. You know, x gives me y. That kind of lines up with our understanding of algebra. Okay? So let's take a look at what is a scatter plot. Right, so let me clear the screen here. Okay, so a scatterplot is basically a graph of how the explanatory variable and the response variable, or two measures, it doesn't even have to be explanatory and a response variable, relate to each other. So you have, let's say, measure 1 here, which if there is an explanatory variable, that's where we put it. And then you have measure 2 over here. And if there is a response variable, we're going to put it there. Oftentimes we call this variable x. Oftentimes we call this variable y. All right, so let's say I now have a measure here, And I've got another measure going this way. And these are both quantitative measures, right? So I'm going to put dots on here. So I'm going to measure individuals. And each individual that I measure gets measured two ways. It gets measured number one, gets measured 2 and 2. So it could be like calories consumed, weight gained, arm length, height, right? So let's say I start plotting the X and Y values for where these people lie, right? So maybe this could be my calories consumed and weight gained, right? I would think that as I consume more calories, I will gain more weight, but it's not necessarily like, so there we go. I've plotted a bunch of individuals and now I have a scatter plot. And this gives me an opportunity to, so this is a scatter plot. This gives me an opportunity to examine something that we call association. Okay, and association means like, does this variable and this variable have some sort of seeming association? And in this scatter plot, we would say yes, these seem to be associated. And in fact, they seem to be what's called positively associated. Okay, so positive association means that as the one gets bigger, so does the other, or vice versa, as the one gets smaller, so does the other. We don't necessarily know which one's causing which, or even if that's even they're being caused at all. Okay, because we can get into like, how does association happen where one is not a causal agent, which is an interesting bit. But at the end of the day, we're getting that like, is we measure in a population of individuals. If the one measure goes up, so does the other. One goes down, so does the other. We call that positive association. So on a scatter plot, that's going to look like the dots that are going up and to the right. Okay, so if we have a positive association, we also are going to have what we call negative association. So let's take a look at what that looks like. All right, so scatter plot with negative association is still going to be like measure 1 and measure 2. But now, like, my scatter plot, when I graph out the population, is looking more like going, it's trending down and to the right. So as measure 1 is increasing, measure 2 is decreasing. And as measure 1 decreases, measure 2 increases. So they go in opposite directions. This is what we call negative association. Okay, so it's going to look kind of like down and to the right. It's going to be the general trend of the dots in the scatter plot. It's going to give me negative association, which means like when one goes up, the other one goes down, right? So like, if I run faster, then the time of my race, the time it takes me to complete the race decreases. So those things are negatively associated, okay? So not every set of measures are associated. So let's draw what happens when you get a set of measures that are not associated at all. Okay, so if I have like measure 1 here and measure 2 here, and I get like hot mess, just like white noise. Something like this, where I don't see a trend in either direction. We would suggest that this has no association. Like, if I pick a particular value of measure 1, so let's call that x1, like, I haven't a clue whether x2, where x2 might actually be. Like, it could be anywhere. So there's no way to make an association between the x variable and the y variable. So this is like, it just looks like a hot mess, kind of noisy. So I would assume that there is no association there. Now, we're being a little bit like, I don't know, almost hand wavy at this, and it would be nice to be able to put some numbers to this. So let's go ahead and do that. All right, so correlation is a measure of association. Okay, so what happens here is we call the correlation coefficient R. That's our name for it. And the way you actually calculate this thing is you use 1 over n minus 1 times the sum, and then it's all of the x values minus their mean over the standard deviation of the x's times all the y values minus their mean over the standard deviation of the y's. So this is like z-scores for the x's times the z-scores for the y's for each individual multiplied together, added up, and then divided by n minus 1, which is that like mystical n minus 1 that happens in standard deviation. But if I actually divide it by n, I get some problems there. So we're going to let that be n minus 1. So what's going to happen here is this number is going to be a number between -1 and 1. Okay, if I am close, if r is near -1, then we are strongly negatively associated. So if my correlation is near -1, then we are strongly negative associated. If r is near 1, we are strongly positively associated. Okay. And if r is near 0, we assume that there is no association. Okay, so like, why does that work, right? Well, if I have negative association going this way, then when x is big, this is going to be positive, which means y is going to be small, which is going to make that negative. So positive times negative is negative. If x is small, this is negative, and y will then be big, which will make that positive, which is negative times positive, which is negative. So either way, when I have negative correlation, this all comes up as negative. I add up a whole bunch of negative numbers, I get a negative, divide that by n minus 1, I'm going to get a negative. So that's why I'm going to be going to the negative side when I have negative association. Likewise, if I have positive association, this is either going to be positive times positives, or it's going to be negative times negatives. Either way, positive times positive is positive, negative times negative is positive. I'm adding up a whole bunch of positives and dividing that by -1, which means that I'm going to get a strong positive association, right? If I have like some of these coming up as negatives and some of these coming up as positives, then they're going to cancel each other out, which is going to put me really close to 0, which is going to show me to have no association. Okay, so this is my correlation coefficient R. It gives me a chance to understand numerically whether or not the data suggests that I have a strong negative, a strong positive, or no association by how far I get from 0 to -1 or 0 to 1. Okay, so what do we have here? We have a scatter plot is a sketch of how two measurements taken of a set of individuals relate to each other, right? And then from the scatter plot, we can visualize the association between those two numbers, positive if it's up and to the right, negative if it's down to the left, no association if I have a hot mess, like just noise. And then we quantify this using this correlation coefficient, and it's going to give me a number between -1 and 1, which is going to give me an idea whether I am strongly negative, strongly positive, or just not associated at all, or somewhere in between. You're going to find a way to do this using the calculator. You're almost never going to calculate R by hand. It's actually part of the regression functions on the calculator, and we will show you how to do that sometime this week. All right, I hope this was useful, and we'll see you in class.